creek here. All right, but straight down this way, you can see this cordgrass, Spartina and Juncus marsh. And if you take a look at where the trees start, it's anywhere between 10 to 12 to 20 some odd feet back from the marsh area. Now, the reason is why these trees are back farther from the marsh is this Long Creek. Now, if we keep following Long Creek out, it goes up to the Lynnhaven River. If we follow the Lynnhaven River, it goes over to the Chesapeake Bay, and the Chesapeake Bay, of course, comes into the Atlantic Ocean. So we have salt water from the Atlantic Ocean. Chesapeake Bay is salt water. Lynnhaven River is kind of a mixture of brackish between salt and fresh, and the farther away from the ocean and the bay it gets, it becomes much more fresh. Now, Long Creek is coming off of the Lynnhaven River. There is salt here in the Long Creek. So the trees do not like salt water whatsoever. But the grasses, the cordgrass, Spartina and Juncus, they are adapted to being able to live in this very, very salty environment. So what we're going to see in our data, we're not going to collect data here today. We're going to the swamp to collect data. But you're going to see that the salinity of the water here at Long Creek is going to be much more saltier than it is at our swamp. So that means that we're going to see very different kinds of plants from the salt marsh to where we are in the swamp. Okay. Now, also, we have, if you take a look, because there's not a lot of trees where the cordgrass is, okay? It's very sunny, very open, lots of sunlight here. So it's much different conditions in the summer, much kind of warmer temperatures in here because of the sun. So we're going to see some real differences in our physical environment here versus the physical environment in the swamp. Now, right in front of you happens to be a pine tree. These two big ones, or three big ones that are right in front of you, these pine trees right here. This is shortleaf pine, and if you take a look at it, there's just all sorts of pine cones all over the place on it, okay? And if you take a look at your feet, there's some pine needles down there, and there's some mixture of these pine needles. So we're going to get some that are long, okay? But we're also going to see some that are very short, okay? Some of these little short leaf ones versus the long ones. So if we were to take a long one and compare it with a short one, okay? This is probably from that pine, or probably that pine right there. This is our most common pine right over here that doesn't have as many pine cones. It's called loblolly pine, Pinus tata, okay? And this is shortleaf. If we take a look at how many needles are in one of these little bundles, we call these bundles fascicles, there's 3, and the needles are twisted. We take a look at the shortleaf pine, 2 needles. Okay, so most of the pine trees, you can look at, sometimes you can look at the bark, sometimes the barks are different. Now in this case, the barks look very similar between that loblolly and these 3 short pines. But you can really tell with their needles and their cones. So if we take a look at some of the shortleaf pine, little teeny cones, little tiny teeny ones. Okay, the loblolly ones are much bigger. Okay, now these even have what we call little prickles on them, and the loblolly cones, yes, here's one. Okay, these loblolly ones, really sharp little prickles on them. Now this happens to be a female cone, and it got knocked off the tree before it was really ready to be released. And then these are normally the green ones you see after the big storm sometimes. And the scales are open just a little bit to allow the pollen to get in, and then they close up, and for a year the sperm travel to the ovule, to the egg, and start development. So it takes almost 2 years for a pine seed to go from egg and sperm to seed. Okay, when they're ready to be released, then they dry up and their scales open up like this to allow the seeds to come off. Okay? All right? So this is a little bit of the Spartina salt marsh. Unfortunately, you know, with the state parks and everything, they try to designate certain areas for conservation only. So there will be no building in this state park. But across Long Creek, these houses have been there for 40 or 50 years, right? And a lot of times with conservation, you have to balance conserving land and then allowing humans to use land. So for the grass and trees over here, they have to deal with the fact that there are humans that are living over there that are basically, you know, not really trying to, but they do pollute the water. Okay, there's boats in the water. That means chemicals, oils, gases, and those kinds of things. Number two, there's pools over there. So in some cases, some of the pools, if they want to drain it, some of that water gets into the Long Creek, so there's chlorine or salt in there. Also, there's fertilizer on those yards that runs off, and so now you have nitrates and phosphorus coming into Long Creek, which could possibly do some eutrophication. In other words, kind of pollute the rivers. But most of the time, you know, humans are trying to do the best they can without making too much of a mess. But in conservation areas, it's very, very difficult to find pristine areas. So on the edges, these conservation areas have to deal with human impact on them. Okay? All right, so now we're going to go back a little ways